Good morning, sì, good morning, good evening. Buonasera, buonasera a tutti, siamo tornati qui in questa nuova live Leet Coding Together, ok? Allora, direi di partire anche abbastanza velocemente perché comunque sono alquanto stanco dopo tutte queste giornate a fare lavoro, studio, lavoro, studio, lavoro, studio. Ma noi ci siamo qui, stiamo andando avanti. Finora abbiamo fatto 10 su 10, per lo più easy e middle, nessun hard al momento. A breve comincio a parlare solo inglese. Ricordo che qui noi studiamo per passare un futuro, chissà quando, chissà come, chissà se passare una interview, in questo caso a Google. Ok? Ascoltatori Google, ci stiamo preparando per voi. Allora, dove siamo arrivati finora? Abbiamo risolto tutta la parte di array and hashing. Stiamo vedendo gli stack. Cosa sono gli stack? In italiano le pile. Sono, chiamiamole, delle liste che però danno la possibilità di accedere lettura e scrittura solo all'ultimo elemento inserito tramite quella che è la proprietà. Possiamo dire la proprietà? Vabbè, la cosiddetta LIFO, last in first out. Quindi ogni volta che noi inseriamo sempre come capo della lista, dello stack, della pila. Quindi immaginiamo di impilare una serie di libri. Questo è l'ultimo libro che mettiamo, sarà in alto a tutti e sarà anche il primo libro che toglieremo per andare a leggere i successivi. Ok? Abbiamo già effettuato i primi 3 esercizi con alquanto una buona facilità. Ricordo, è vero pure, che però i primi 2 li avevamo già visti praticamente nell'esempio quando abbiamo studiato proprio gli stack. Faccio riferimento all'ultima live di coding, di Leet Coding. Scusate se mi mangio le parole oggi, ma così. Questa settimana è un po' massacrante. Comunque, poi magari chissà potrei riuscire a... No, scusate. Potrei riuscire a tagliare il pezzo della live in cui studiamo lo stack e farne un video, o magari scriverò sul mio blog. Ricordo che ho un blog, ricordo che ho un canale YouTube e Twitch dove vi state vedendo, LinkedIn, GitHub e quant'altro che intanto non mi interessa. Cominciamo con daily temperatures. So, let's start to talk in English. Parlerò in inglese. Mi sono schiacciato il dito. Che dolore. Che dolore. Fatto malissimo. Scusate. Sono schiacciato il dito, dell'unghia del dito, dell'indice. Comunque, perché parlerò in inglese? Perché nei colloqui uno deve spiegare il codice in inglese, fare domande in inglese. Quindi non ha senso che parlerò, non ha senso parlare in italiano se poi in un futuro futurissimo uno parlerà in inglese. Va bene? So, daily temperatures. Given an array of integers, temperatures, represent the daily temperatures. Return an array answer such that answer iesimo is the number of days you have to wait after the iesimo day to get a warmer temperature. If is no future day for which this is possible, keep answer equal to 0 instead. I'm sorry. Okay, so let's reread, please. Given an array of integers, so we have some temperatures, I have to represent the daily temperature. Returning an array with its elements. The elements of the array is the number of days you have to wait after the iesimo days to get a warmer temperature. Ok, quindi so if today, let's put we have okay, let's use this day examples. You have this temperature 73, 74, 74, 75, 71, 69, 72, 60, 76, 73. You have a warmer temperature after 1 day, then after 1 day, then after 4 days, then after 2 days, okay, and so on. If you don't have warmer temperature, you put 0. This is clearer, and this is clearer. Okay, so what's the answer? What's the question we can do to our interviewer? We can say, I will always have an array with integers, or can I expect an empty array? And in that case, what I must return? I will say an empty array. And they can reply to us, you will always find an array with at least one element inside, okay? And all the temperatures are between 30 and 100. So you know that if you encounter 100, you will always get 0 without checking something. If you encounter 30, you will always save 1, okay? Plus or minus 1. Because you can have only 30, 30, 30, 30, 30. You must check for a warmer temperature. We don't know if we don't know what we have to do if 2 days have the same temperature. I think we must skip it, okay? Because we only want a warmer one, okay? So how we can do that? I think we can do in 2 for. I think a for in a for. Yeah. I would do a for in a while, maybe. Okay. Maybe a for in a while. Or maybe we can just read by reverse the temperature. Maybe we can read by reverse the temperature. So the last is always 0. Then we have we know what number is it. We already saw it. So we can just say, okay, is it warmer or not? Not. So it's 0, is 1, is 1. This, how do you know? No. Okay, let's put I will do like that. Cycle temperatures. Okay, then inside I will cycle again temperature, quindi temperatures i. Then I will cycle again it, but with e plus 1. Sorry, e plus j. Okay, just to see the next ones. Okay, and then I will save it in an array. Semplicity. I will save in array results. I think this is okay. Probably is not the best. Maybe it's not the best. But let's try to think if we can do something better. Okay. You know that you have to read the current temperature of the day, and you have in some way you have to check where will be the new warmer temperature. Let's try to put it to write this. Let's try to write this solution, and then we can try to implement a better one. Okay. So of course, if it's only one element, I will put it 0. Okay. So if temperatures dot length equals 0, return 0. Okay. Then we have an int array. Okay, we have an int array result that is new int of temperatures dot length. Should be like that, if I remember well. So we can free some space of memory. It's not so relevant, but that's okay. Then for int e in int e equals to 0. Let's start for the first. E temperatures dot length minus 1. Okay. E più, sorry, e plus plus. Okay, so we are constructing the cycle. What we have to do? If okay, let's int temperature equals to we can say current temp equals to temperatures I. Okay. If current temp equals to 100, we know that this is the maximum. So resultissimo is 0. Result equals to 0. Okay. And you can continue with the next one without doing nothing more. Okay. Then we have to check the sorry, I am thinking how to do a better solution, but for now just int next e equals to e plus 1. Okay, sorry, yeah, equals to I plus 1. Of course, they also have, sorry, this is okay, and this is okay. Okay, so oops. Now we have to check for the next index to see if there is a bigger one. Okay, maybe we can do with the find without doing another for. We can do with the find. If you find it, I need to know also the index where you find it. So okay, just do like that for the moment. So int next temp equals to temperatures next e. If next temp is greater than current temp, you have to result e equals to next e. Okay, and then you can break this cycle, this small cycle, because you don't need anymore. Okay, and then you will continue it because okay, but how I know that I did? Okay, we can save a variables. We can save a variable that is int next warmer index equals to 0, and if you find something you will put like that and break the cycle. So when I arrive here, I just do result e equals to next warmer index. Okay, at the end we return result and we did it. So it should work. Wait, I'm sorry. Yeah. You know, I know. Minus C, because we have to take the next one, not for this. Now it's okay. Okay, but I'm asking myself, I'm doing a stack LeetCode, so there should be a better solution using stacks. Okay, let's try to submit this just to save it. Okay, but of course it's not the best solution. Time limits exceeded with all 99. Yeah, that should be all zeros. So and 100. Oh wow. Okay, so just to know, the complexity should be quadratic, of course. Yeah, of course. What we can do? what we can do. This is the solution we implemented. Okay, so we cycle temperature next, and then we just do the check. Of course, it's a quadratic one, so it's not a good idea. What we can do to reduce the complexity, and an int should be using stacks, because we are doing a stack LeetCode, so should be the solution should include the stacks. So this, let's repeat. The stack is used to read the last element we insert inside it. Okay. So what can be useful for us? How can be useful for us? How can be useful for us using a stack? Let's think. Oh, thank you, Mr. Emilix TV. Thank you for the subscribe. And I think I have also... Yeah, Mr. Emilix TV. Thank you. So. Oh, also Emiliano. Thank you, Emiliano. Grazie, Emiliano. What we can do? Okay, we just... Let's try to think. Okay, let's say we can ask an int to our interviewer. Okay, the int is, if temperature is say 70 today, then in future a warmer temperature must be either 71. We will remember when all of them occur next. If the temperature is say 70 today, okay, we are at 70 today, 73 today, then in the future a warmer temperature must be either 71, 72, 73, 99 or 100. Of course, this is the check I'm doing. We could remember when all of them occur next. Because you say, if you already check if you already checked all the numbers and you know at what index you will find a 71, you don't have to cycle of the elements twice or more. Maybe this is the int. If this is the int, I would say that I don't know. I really don't know this time. And the fact that I know that I must do the stack is not help me. It doesn't help me. I have to use stacks. So maybe I have a stack of numbers and a stack of index. I don't know. Or maybe I mean, with the stack I can read only the last element. So why I would use it for this problem? Why? I'm in difficult. Guys, I'm in difficult. Let's try to understand better with some other. Please don't share code here, blah blah blah. Next greater element E. Assume that index are days. No. Number of days, 284 more separator. Zero 73 need to wait 1 day because the word. Okay, blah blah blah. We understood. 6 minutos, so on. Take these values in monotonic stack to find the higher number. We can see that we need the next greater element for every number, right? What we can do is make a stack and push index 0 in it, because for index 0 we do not have any greater element right now. Check for every index from 1 to n. If element less than its number are present in stack, just keep on popping them. If element less than this number are present in stack, just keep on popping them and update in your answer array different index of both of these. Push the index for which you were checking in the stack. What? So we pushed 0 in stack. Now we check it for index E1. It's 74. Then unless this 73 is present in stack. So we did. Now stack is empty and we had the index 1 in stack. And element leader 74. And for E2 will be the same procedure. Now stack will have 2 index of 70 after E equals 2. 4. Okay, you have here. Now you have 71. We can see that only index 3 is greater than 69. Zero, 1, 2. Oh, sorry. 1, 0, 1, 2, 3. Okay. So we pop index 3 and push the current index here, 4. I didn't understand this. I have to read it because I'm not understanding from this. It's not a good at runtime. But I just want to the discussion is not making me clear. Without getting TLA. What is TLA? Two-line element. So it's again a stack question. This time you use a monotonic stack. In fact, the optimal solution runs in 0n with space needs 0, 1. 1, 1, 1, 2, 3, 4. If I don't understand question, like I like to first one answer. Okay, let's try to read how what is it a monotonic stack. Is a data structure that maintains elements in order, strictly crescent or decrescent. Okay, so we miss a part. We are missing a part. So a monotonic stack is a special kind of stack. Whoa. Okay. Which maintains its element in a specific order. Unlike a traditional stack where elements are placed on top of one or another based on when they arrive, a monotonic stack ensures that elements inside the stack remain in an increasing or decreasing. Okay. So I was missing this stack, this type. I never used a monotonic stack. This is achieved by enforcing specific push and pop rules, depending on whether we want an increasing or decreasing monotonic stack. For a fortune code interview due to their unique capabilities, they are particularly effective when it comes to problems requiring us to find the next smaller or larger element in a sequence. NG and C. Monotonically increasing stack. A monotonically increasing stack is a stack where elements are arranged in ascending order from the bottom to the top. Okay. Here, every new element that pushed onto the stack is greater than or equal to the element below it. is greater than or equal to. Ok. If a new element is smaller, we pop the elements from the top of the stack until we find an element smaller than or equal to the new element, or the stack is empty. This way, the stack always maintains an increasing order. Ok. Ok. Conversely, a monotonically decreasing stack is a stack where elements are arranged in descending order, from the bottom to the top. When a new element arrives, if it's larger than the element on the top, we keep popping the elements from the stack until we find an element that's larger than or equal to the new element. Or the stack is empty, this is the stack. When to use monotonic stack? Here's some key aspects. Monotonic stacks are typically useful when dealing with problems that involve analyzing sequences or arrays, especially when you need to find the next or previous larger or smaller element for each element in the array. If you encounter a problem where the solution seems to require some sort of sequential step-by-step comparison, it's likely a good candidate for a monotonic stack. So this is our case, okay? One classic scene that the monotonic stack might be helpful is when the problem description mentions find the next greater element or next smaller element. Problems that involve finding maximum areas, such as histogram, can also be solved effectively using monotonic stack. Remember, the key is to identify patterns where sequence a step-by-step comparison. Understanding how to build a monotonic stack is key. We'll break down this process for each type. Okay, monotonically increasing stack is a general structure of monotonically increasing stack in pseudocode. For each element, we create an empty stack. For each element in the array, while stack is not empty, and top of the stack is greater than the current element, pop the stack, then push the current element to stack. This logic guarantees that for each element, all larger elements preceding it get popped. Leaving the next smaller element if it is at the top of the stack. For each element in the array where stack is not empty and top of the stack is smaller than current element, pop the stack, push the current element. This structure ensures that for each element all smaller elements preceding it get popped, leaving the next larger element if it exists at the top of the stack. They pop out the elements from the stack that are larger or smaller than the current element. I'm not understanding it. I'm sorry. I'm sorry, I'm not understanding. So, if I have to report in this problem, I put 0. Then I say, okay, no, I want the 1 here and the 0 here. But how I know that? I want the smaller one at the end because it's okay. Let's say I want the small numbers at the start. Okay, at the top of the pile of the stack, because I know that the last element is always 0. So in this case I would say like we always know that there is an element. Sorry. Okay. Then I do a stack int result equals to an empty stack. Okay. Then for int equals 0. Okay. I should not need it. How I know? No, I'm not understanding. If here I save all the numbers, let's say I want to save indexes here. How can I know? Okay, so 73 is 0. Then I go here and I check the previous one. I say okay, no, okay, is 1. Perfect. Then I go here. I say oh, also this is 1. Okay. Then I go here. I say sorry. I go here. I say no, the previous one is not 1. It's 2. Recap. It's 1. Is greater, so from 0 it passes to 1. Array insert. I'm not understanding. Sorry, I'm not arriving to it. No. I want to know the solution. In this problem we are given a list of temperature where the temperature at index C represents the temperature of the... Okay. Our goal is to, for each day, find the number of days until the next day. that is warmer than the current day. Often the best place to start solving a problem is considered a brute force approach. The naive brute force way to solve this problem is to iterate through the array, and for each day iterate through all the remaining days until you find a warmer temperature. And this is what I did. Until the day in a row with the decreasing temperature and the one very hot day. The final day is the answer. Day for all the other days. Why? Because all the other days are in descending order and cooler than the last day. If you make us the fact that temperature in descending order can share the same answer, day, we can improve the time complexity. In above example, we can delay finding answer for the first 7 days. And upon finding a warmer temperature 65, we can move backward to find the answer for all 7 days at the same time. Okay. I understand this, but I'm not understanding how you can do it. Let's look at data structure known as a monotonic stack. Let's fork it. Oh, no. Can remove the fork. Okay. So. What if I would like to know something? No, it's all LeetCode, okay. A monotonic stack is simply a stack where the elements are always in sorted order. How does it help us? We can use a monotonic decreasing stack to all temperature. Monotonic decreasing means that the stack will always be sorted in descending order. Because the problem is asking for the number of days instead of storing the temperature themselves, we should store the indices of the days and use temperature C to find the temperature of each day. Monotonic stacks are a good option when a problem involves comparing the size of numeric elements with their order and behavior irrelevant. On each day, there are two possibilities. If the current day temperature is not warmer than the temperature on the top of the stack, we can just push the current day into the stack. Since it is not as warm equal or smaller, this will maintain the sorted property. Okay. If the current day's temperature is warmer than the temperature on top of the stack, it means that the current day is the first day with a warmer temperature than the day associated with the temperature on top of the stack. When we find a warmer temperature, the number of days is difference between the current index and the index on top of the stack. We can declare an answer array before iterating through the input and populate answer as we go along. When we find a warmer temperature, we can stop after checking only one element on the top. Using the sample 75, 71, 69, 72, once we arrive at the last day, our stack looks like 0, 1, 2. 0, 1, 2. Okay. 72, the current temperature is greater than 69, but it also greater than 71. But here, how we know it? We must put 1 and reverse, flip it. To make sure we don't miss any days, we should pop from the stack until the top of the stack is no longer colder than the current temperature, until the 0, right? Once that is the case, we can push the current day into the stack. You have to write to 0 and put 1. No, you put the difference between 4 minus the first day when we find the warmer temperature, the number of days is different between the current index and the index on the top of the stack. So this is 2, but it's not correct. This is 0. Not understanding. 0, 1, 2, 3 minus 2 is 1. I don't know. Really. Initialize an array answer with the same length as temperature and all values initially set to 0. Also initialize the stack as empty array. Initialize an array answer with the same length as temperatures and all values initially set to 0. And this I did this. Also initialize the stack as an empty array, so I'm just trying to find out indices. Okay. Iterate through temperature at each index car day. Okay. We can remove it. Okay. If the stack is not empty, that means there are previous days for which we have not set yet a warmer day. Oh, okay. While the current temperature is warmer than the temperature of pref day, the index of the day at the top of the stack. Answer pref day. Okay. Now I understand. Okay, so this is current day. Okay. Okay. It is saying if current temperature, if the days, let's say days. If days dot maybe count equals to 0, is bigger than 0. Let's say is bigger than 0. There are previous days for which we have not yet seen a warmer day. Ok. While the current temperature is warmer than the temperature of prev day, the next index of the day at the top, the index of the top day at the top of the stack. So we can say prev day int prev day is equals to days dot peak. Ok, iterate through next temperature, through the temperatures. No, sorry. Set answer prev day equal to the number of days that have passed between prev day. Okay, if the current temperature is warmer, if current temperature is warmer, we can say we can do pop. Sorry, we must pop. And we should say if prev day, sorry, if temperatures current day is bigger than temperatures previous day. Ok. Ah, shit. Ok. We can say that result the previous day okay, is equals to current day minus previous day. Okay. And this should be while the current temperature is warmer than the temperature of prev day. So we should do a while. I think we should do a while. While this it's not an if, but this is a while. Okay, and then we say prev day if I don't know if I'm doing this right, I'm not sure. Then days dot push current day. I'm not sure, but okay. Sorry. I'm not really sure. Yeah. I'm not sure that I'm understanding. Let's try to read what I say, what I did. If days count. Oh, sorry. This must do always. What? Maybe it's not a while. No, sorry, I didn't understand. So, stack is empty. Then it means today is the first day with a warmer temperature than day one. No, sorry. The stack is empty for the first element, so push the first element to stack and move on. That means today is the first day with a warmer temperature than day 0. Set answer 0 equals to 1 minus 0 and 1 and pop from the stack. After popping, the stack is empty, so push the current day and move on. That will be 1. That means today is the first day with a warmer temperature than day 1. Set answer 1 to minus 1 and pop it from the stack. After popping, the stack is empty, so push the current day and move on. So should be an else. $71 is not warmer than 75, so just push it onto the stack and move on. Oh, I deleted the if. Okay. It's not warmer than 75. So this is peak. I'm sorry, I didn't realize that, and it's not a good move. Just 71 is not warmer than 75, so just push it onto the stack and move on. Okay. Then 70 9 is not warmer than 71, so just push it into the stack and move on. Ok. Seventy-two is warmer than 70. Blah 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 blah. Set answer 4 equals 5 minus 4 and pop from the stack. Okay. So that's a while. There is a while. 72 is warmer than 71. Set answer. I'm not understanding. I did it well. It was a good while. Correct. missing something. Is the late hour, I don't know. In 10 equals temperature document. Only Java and Python I have. Let's say Java. Current temp. If here is not interesting. Okay. I say I do like that. I'm copying it, but I'm trying to understand it. Really. Okay. I just say okay. This is what I'm missing. I was missing. It's 0n and this is 0n. Okay. Array optimized space. Okay. Okay. We did it with a bunch of problems, but we did it. I would like to do another one. It's late, but okay. Sorry, I replied to my mom. Okay. I'm sorry, I'm stressed and tired. It's late, it's really late. But that's okay. That's okay. We're doing for a reason. We are doing it for a reason. And I want to I need some sleep. Really. Ok. So let's try this one. There are n cars at given miles away from the starting mile 0, traveling to reach the mile target. You are given two integer arrays, position and speed, both of length n, where position e is the starting mile of the iesima car, and speed is the speed of the car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. Okay. A car fleet is a single car or a group of cars driving next to each other. The speed of car fleet is the minimum speed of any car in the fleet. If a car catches up to a car fleet at the mile target, it will still be considered as part of the car fleet. Okay. Return the number of car fleets that will arrive at the destination. This is very difficult. At this hour, it's late and it's difficult. But okay, we can try. So one example is target is 12, position are 10, 8, 0, 5, and 3, and speed are 2, 4, 1, 1, 3. So the first one will arrive alone. 10 plus 2 will arrive alone. The second one will arrive alone because she will do 1 mile only. Okay. They will arrive together, sorry. They will arrive together. At the end, they will meet themselves at the end. Okay. Then this will arrive only alone, sorry. These 5, 6, 7, 8, 9, 10, 11, 12, 7 miles, and this 7 hours. Yeah, and this 3 miles per hour, so 6, 9, 12, 3 hours. No, they will meet each other at the first hour and then they will go at the slowest speed. Wow, okay. I understand the question, but ok, focus, yeah. Sì, facciamo quest'ultimo e basta, il secondo di oggi, sono tosti. Target 10, position 3, speed 3. This is the only one car and there is only one fleet. Ok. Target 100, position 0 to 4, speed 4 to 1. The car starting at 0 speed 4. Io mi fleet machine. Ok, so the or the length are the same. and there is always at least one element. The target is between 0 and a large number. The position is between 0 and the target. All the values of position are unique. Okay. And the speed is between 0 and a large number. Okay. Okay. Maybe we must use like the stack we used before, but I'm not sure. Okay, let's try to do a brute force one or something similar. Then we will try to. I would like to do something like I'm trying to think. We should make a way where all the positions are updated instantly, summing the speed, of course, adding the speed. Okay, so i car che non passano del car. So if I am the top car, we should order them. We should order. If we order, let's try to start with this. We have position 0, position 2 and position 4. Already ordered position and speed. That is 4, 2 and 1. And then we have target. $100. Okay. What we can do is car 1, we know that is post 0. Well, speed for every hour mile per hour. Okay, car 2 and car 3. We have 2 2 and 4 1. So after 1 hour we have start hour 0. We have this, and we have position 4, and position 5. At this time we know this will become a frit, so they will unify it and will do G1 plus G2 position 4 with the minimum of 2. So we will have this situation, and after 2 hours, hour 2, we will have that this will be position 6, this will be position 6, and they will do the same stuff. So will be C1, C2 plus C3, position 6 and mile per hour 1, and we can return 3 because we are sure that they will proceed the same. Okay, so say that we are thinking about a while the target is not reached for all the cards, I must continue to cycle. Okay, so I'll cycle only the target. Okay, I will cycle all the position, returning the minimum position. If the minimum position will not arrive at the target, we will continue to cycle, and this is one thing. The second thing is we have to thinking a way to update all. I don't have, yeah, I have to update the position, but it's okay. And I need to update all the position and then check and update all the position and then check if speed, sorry, if the position updated is equal or not. Ok, so is simpler there then we can then I thought say well while how can I retrieve the minimum? I will just say minimum int min pos equals to the first one. Okay, so position 0, and that's okay. Then while min pos we know that the position is always under the target. Okay, if we have one car, the output is 1. So if position dot length equals to 1, return 1. Instead we have to do all the check. Okay, while min pos is while target is greater than min pos, we must do that. Also this int fleet car fleet equals to 0. Okay, and int cars equals to position of length or car fleet. I'm sorry, it starts with 0 car fleet. You don't have car fleet. No, you have all car fleet. Okay, you have all car fleet. So car fleet is cars. And if you have one only car fleet, okay, if car fleet equals 1, sorry, is bigger than 1. If it's bigger than 1, you continue. If car fleet is 1, you are sure that they will arrive all together, and then you can return the car fleet. Okay, then what we must do now, we must cycle all the position. Is irrelevant the order. Okay, so for int pos in pos equal int equal 0 e cars e plus plus. Okay, instead of cars should be car fleet, but that's okay. What we can do, Instead of cars should be car fleet. Maybe later. Okay. For every car, we will look at the minimum position, but after, not now. Now what we can do? We must increment all the position for the speed. So position E equals to cars, sorry, to position E plus, so this is plus equal speed E. Okay, then what we can do? If so this is the first one, the first step. As after they is passed 1 hour, let's say if passed 1 hour, if position, how can I know if there are other positions? I should check again all the stuff, or I can use a monotonic stack like before. In the stack I save the position. If I have another I order the positions to have the bigger one at the bottom. Maybe. And I want to clean it or not. After a while cycle I want to clean it. Maybe yes. After an hour I want to clean it. Let's try. I'm not sure what I'm doing. We have to reorder it every hour. Okay, I want to reorder it every hour, so new position count while new position count is 0. Yeah, I want the minimum at the start. Ok. We can say car fleet. If new position is bigger than the peak, what I do is to if the new position, if this position is bigger than new position dot pick, I want to put it down, so I have to I'm not sure what I'm doing. Okay, I need to sleep, so we will straight focus on the solution, but I think we will near. I will near. I am near. We must use the stack to reorder all the cards and so on. Goal that lead fleet the fleet farthest position in the card S. Behind the card first would arrive early at the S from. I don't know. I never used the monotonic stack. I don't think. Also, they aren't using here. But should be an approach with stack. using a tree map. Okay, we can skip this. We will skip this. Okay, for today it's all. I need to sleep and I think I'm wasting my time to solve this problem. Okay, so this is the solution I will give. I will give this solution. It's not correct also this. Okay, for today is all. Thank you everybody. Have a good night. See you tomorrow.